Thank you for joining our GTC-DC AIDP presentation featuring Hammerspace and NVIDIA's RAG reference architecture. To start off, we're going to Remote Region 1, which is a draw for a country of interest, Remote Region 2, which is very similar and have a field office in Region 3 with a handful of field analysts there. And then we have the Intel Hub. That's basically Langley, where all the compute is, and collecting information, and finding targets of interest. So there's a bunch of AI agents looking for things in this particular scenario, as well as a pool of analysts. The idea is that when someone shows up from our intelligence community and drops files into a region, then our global namespace is enabled for that particular group of location. That means all of the files will show up instantaneously in the other locations, except you notice they didn't show up in Region 2. This is because in a global namespace, we also have the ability to partition certain files and place certain files in different location. So we're able to do this all with policy. What happens is when these files are dropping, we have an objective that automatically starts moving those files through to the intelligence hub. From a durability standpoint, if something were to happen to that remote office and drop location, we have a mission complete in another region, and they're collecting a whole bunch of files and laptops and hard drives. The second those files are copied into that particular drop location, and now they're instantly available in other ones, meaning that a field operative in a remote region can now start looking at those files remotely, and our built-in objectives are able to automatically go to start moving files. As soon as they drop, they land up in the intelligence hub. So let's talk about the process. We go through Hammerspace's AI Data Platform, built on top of NVIDIA's AIDP solution, to make the information embedded and constantly available in a cleansed AI format for these parts, and for the LLMs, for an analyst to start pouring through things. Let's dive a little deeper into what we're doing inside of Hammerspace. What happens is these files are copied into an S3 bucket, and obviously we're storing petabytes worth of data inside of the Intel Hub. So we really want to be highly economical, but we need to process those files. It needs to be very fast. So what happens if we recognize those files are new? Our MCP server with a file policy agent and a Hammerspace toolkit will control objectives and tag that file to get processed. As soon as the file is tagged, MCP and objectives will then move that particular file onto Tier 0. And as we talked about, Tier 0 is our NVMe tier inside the GPU servers that we use to create a unified portion of storage that is incredibly fast. We can move those files from their original location to be processed in ultra-low latency and high parallelism, but those files land, get tagged, and automatically moved. We can use this pipeline to do instant embedding. This is the part where NVIDIA's AI Data Platform comes in. We have to use NeMo Retriever and the embedding process to index all of the files. This is the process of turning all of the emails, text files, PDFs, and anything that's on the hard drives into actionable intelligence. Once that process happens, we're through validating through our MCP server to make sure that the files are actually in the database as embeddings. We do a quick validation search to make sure the embeddings are present, and then we're able to stage those files from Tier 0, freeing up for the next run. And again, we get instantaneous access to the automated agent or analysts that need to be able to query the documents through the particular intelligence hub. Let's move on to the demo. Up here we have a window that represents the remote site 1, and here we have a window that represents remote site 2. If we run the case copy command, then we will be copying from an external hard disk the team brought in from the field and has isolated a particular case. We'll be copying that right into the remote site hub so that we can do the processing on it. Over here, we have another team that has recovered some data. They put it onto an external hard drive, and they've attached it to a computer in there, copying it over. We can use S3, SMB, or NFS in order to do all these different copies. As they are copied in, we have a real-time thread agent that's going to run in the background, and it's going to look through this and all the previous collections for any actors that have been back. So as a backend, we're going to be looking at a distributed workload. We've got a hit. We got a hit against Agent Whisker Twist, and that's case number 78. Let's come back to that. Hammerspace provides the ability to tier between different types of disk volumes. It uses policies to take the case files that we're ingesting, say 10, And we had a hit against the latest one. It copies it on to Tier 1 so that it's durable and cost-effective. And immediately afterwards, it deploys policy that will promote it to Tier 0. It lives there on Tier 1, but it's moved to Tier 0 in order to be effective for jobs that are going to be running against it. We had another hit. This time it was Giggles McCode. This is the mobility pane of moving from Tier 1 to Tier 0. It gives us visibility into all of the copies and moves that are happening. How do we achieve that? Down here, you can see that there's a policy that allows us to dictate whether it's placed on alpha site, a beta site, or a Tier 0. So we'll tag. We'll put it on the alpha site, and then we'll tag and we'll promote it to Tier 0, and then we'll do an analysis on it. This is where the NVIDIA pipeline comes in. As you can see, we have some collections that are there on the left-hand side. We're going to be looking for 78 remote site 1, so we'll click on the collection and we'll paste our prompt in. And you can see we have an indicator that Stealthy Star Warden's there. And we have some travel plans. You can see between the automated agent capability that we have with the NVIDIA Agent Toolkit and with the NVIDIA Playground, the two of those come together for a really powerful solution of automatic detection and human validation. So that's a view of what we've done from a standpoint of NVIDIA integration with Hammerspace. But a really key part of this is the MCP server's event emission console. You can think of the event emission console as a leaderboard of events that have occurred inside of an MCP server. So specifically, what we should be looking at is things like new files being identified, a folder being ingested, tagged properly, and then being ingested using any ingest into a Kubernetes cluster, or potentially getting confirmation that the outcome from the job that was running on the Kubernetes cluster had dumped key features into the database so that we can consume. The next piece is the real-time debug log viewer. This isn't tied necessarily directly to the MCP service, but it is a log file for helping to debug low-level, so we can see all the steps anywhere that things have failed. The last piece to talk about is how we actually do tagging. On the top right-hand side, you can see place on alpha site and a state equals embedded. The place on alpha site gets applied immediately. As soon as we do the tagging, we will place it on Tier 1. We get alignment, and then we do a place on Tier 0 so that it's right next to the GPUs. And then we get an alignment, and then we proceed. The state equals embedded is used for when we're complete. We're able to see that that's part of the sets that have actually gone through the embedding process. So these are some of the features of our MCP server. Thank you for joining our GTC-DC AIDP presentation featuring Hammerspace and NVIDIA's RAG reference architecture.